Welcome to the Vox Pathfinder 15R channel, and this is episode 7. And in the last episode, we had the power amplifier hooked up, and I was playing the guitar and it was fine. And now we're gonna go and change the get the preamp all set up. Now the preamp is dependent upon this diode D14 that connects the power filtering stage to the rest of the circuit. Without this in the circuit, the entire everything other than the power amp does not see any power. So we're going to go and put that in, but I am not going to replace this, put this back in. On the spec sheet, the 1N4000 series diodes, especially for this one, it says the maximum reverse DC blocking current is 5 microamps. And on my tester, it tests a third of a microamp. And so that seems good, but the thing is, it's being rated at its full voltage. In this case, full voltage reverse blocking is 400 volts. This is only testing at 5. Now, the junction capacitance is great. It's like 0 or 1 or whatever. And this thing is 11 picofarads junction capacitance, the new part. But the spec sheet says typical is 15. That's fine. The problem is, on this tester at the 5 volts, this new part's only showing 2 nanofarads. I subscript R. This part is 330 nanofarads on this 5 volt. So who knows what this is performing at, at the full 400 volts. Well, obviously, it's not going to see 400 volts here. It's going to see the 40 plus 44 volts. But still, in the reverse direction, it's probably acting like a short. And maybe had something to do with this amplifier failing. So we're going to put the new part in and see how it goes. And a family member is probably going to interrupt me in 1 second, as they usually do, but I'm going to keep filming. All right, so let's just pull this chassis. Well, before we do that, let's get this diode bent, ready to go, and I have the diode I want to bend it to, so there's no guesswork. So I'm gonna say, actually don't have much of a choice with this kind of bender. Just gonna bend it like that. All right. I'm gonna clip some of the leads off. All right, so let's see if I can point it in. I'm gonna make sure the cathode's pointing in that direction as per the board. That looks right. Yeah, these spec sheets, they, sometimes in some ways they lie to you, because you might be testing a part, and without realizing, well, hold a second, my tester isn't testing at the voltage that the spec sheet says to test it at. All right, got one leg in. Everything's very crowded. Let's see if I get the other leg in. course, I don't like to run like these rectifying diodes so close to the board, because what if they start burning up? They're supposed to take a lot of abuse, and I don't want it to be in close proximity to the board when it does, you know. Of course, people say, oh, it doesn't matter. I don't know. I'm going to say it does. Okay, sneak that in. Okay. I'm going to use my chopstick of life to shove it in more. You know what? For me, it doesn't have to be all the way in. I'm not a fan. If you think it does, let me know. But I'm talking like the one end. I'm not talking like normal, like diodes, you know, like clipping diodes. I'm talking about like these monsters. Like I'm putting a 1N4007 diode. I don't think you want that to stay in close proximity to the board. Okay. It's not the chopstick I want to use. I'm going to get some more light. I'm working at night. Hopefully that's a little more beneficial to you, the viewer. It certainly will be to me in case there's any components I forgot to reconnect. Of course, this desk is becoming such a mess. Amplifier is not plugged in, so not too worried. Okay. There are the two links. Let's see. Just pre-melt some. I'll just touch one side. Just to secure it better, and then I can just unabashedly hold it in. Okay. Now, is there anything else I'm forgetting? Any open holes? One second. I do know that there is another chip on the board that I have to hook up, but that's not a soldering. That's just the cable. My memory is I have everything hooked up, but you never know. I'm just looking for a hole. Let's see. Before I forget, I'm gonna clip these leads. Okay. Here's the other one. Alright. I'm not seeing anything. Although I wonder if I should just go ahead and touch up all like the pots. You know how pots are, right? But it looks like all the like legs that I lifted should be all set to go. I may want to solder that. That looks like I should solder a little more. Like I did a half soldering. And there's still like the old, like, you know, whatever you call lead free. I don't know if it's lead free, but seems to, even the old stuff seems to act like all the lead free wave solder that everyone complains about. Despite the fact this was built in the early early 80s. Man, I know I'm tempted to want to touch up all these things, but they look in good shape, although I don't know. Well, let's just do it. Screw it. Shouldn't be too hard. Just warm up. Add a little bit, not too much. No big deal. You get all these guys though, they'll like suck out all the old stuff. Although I remember a lab technician in college, and he would just reheat, add a little bit more fresh solder. Wouldn't get too crazy. It's not too bad, I'm already half done. I think the trick is just to, like, you know, hold the iron sufficiently long enough. Before you pull it out. That one actually look kind of weak. So yeah, just go ahead. Just reheat them up. Add a little bit of solder to the soup. And I'm only doing this because it's the stuff that gets a lot of abuse. You know, PCB boards, they rely on the pots bolting up to the front of the chassis to hold the board into place, so it's just a weakness. It's an Achilles heel of PCB board design. That's okay, you know, everything has an Achilles heel. Doesn't mean it's inferior, just that everything's a compromise in life. What you gain with some things, you lose with others. No perfect solution. Alright, I think that about does it. Let's see, a solder joint touching, but it might be the same pad. Just double check. Yeah, it's all the same. That's all the same pad. Okay. I don't know what else to do. So plug this thing in. This is one of the the mounted chips, transistors. It's funny, it seems like on a normal amp, the power filtering, it goes through the first set of caps, and then there's some dropping resistors, and it goes to another set of caps, and they'll power other things at a lower voltage, and it'll go through a dropping resistor and another set of pair of filter caps, and it'll be like an even still lower voltage. Whereas this amplifier only has the first, it seems like the first pair of caps, and after that it's like a clever transistor design that makes it get the lower voltages. I'm not quite understanding it myself. Just that I know that it's not typical design. So I will review this all in the morning, but for now we'll just plug it in and see what happens and hope we don't get a failure. I'm going to plug it in to my isolation transformer. We see everything in here. Okay, we get a little bit of the oscilloscope. Again, I don't believe I'm gonna, because of this different filtering design, maybe it has a flawless property for smoothing out the rectified voltage. You don't get like the little whipsaws like in more traditional amplifiers. All right. I don't know that there's anything else. I can't think of anything else. We'll just go with it, see what happens. Power on that circuit. Variac is turned all the way down. Turn on the Variac. Turn on the amplifier. Turn up the Variac. We have a voltage. Do I have anything? Just have crap. That might be it. That just might be such a superior design. It's really curious. Okay, so I want to measure rectified voltage. So I'm going to put it on 200 DC volts. Okay, I'm at negative 22.4, and what the hell? Well, that's not inspiring. Positive 14.8, negative 20.8. Maybe this is an issue where we raise the Variac and issues will magically go away because, you know, there's many more components. Okay, negative 18. Positive 17.8, because, you know, there's like voltage regulators at 55 volts on the Variac. And so I just turned on the rest of the circuit. So it's no longer negative 19.9. Positive 19.6. I'm at 65 volts on the Variac. Again, we are assuming that I have completely hooked everything up and everything is live. So negative 23.8. I'm just going to see if I get negative 24 on the negative rail. Negative 24.4, whatever. And positive 24.2. So it's balancing out. Okay, 75 volts. I'm sorry if this is really slow. Negative 26.9. positive 26.6. You know, it's been a long time since this circuit's seen power. Negative 29 volts on the negative rail. Positive 28.8 volts on the positive rail, which is very very positive. Well, positive connotation. Negative 30.5. Positive 30.3. So we're only talking 2 volts difference. Okay. Negative 31.7. Positive 31.5. Now we're starting to get in the territory because of the mismatch between transformers. My dim bulb current limiter is going to start glowing, and that's not because of a short. Negative 32.9 volts and positive 32.7. Going to bring it up to 100 on the variac. Negative 33.9. Positive 33.7. Let's bring it up to 105. Negative 35.3. Positive 35.1. Are we seeing this? Yeah, you're seeing it. Okay. How much can I stand on? That's 110 on that, the variac, the printed voltage. Negative 36.3. 36.1. I don't smell anything. I hear just the slightest of hum on the amplifier. Okay, I was hearing noise in the background. Okay, so I'm going to test. That's the last. I've got it on 120 on the variac, but I have the dim bulb current limiters going. Negative 37.6 volts on the negative rail. Okay, positive 37.4. Negative 37.6. So it's within 2 volts. Okay, so I don't see anything. So switch off the variac. Switch off the amplifier. And what I'm going to do is now I'm just going to plug the amplifier straight in to the voltage. It's still going to be protected by the dim bulb current limiter, but it will not be going, it'll just see straight voltage. So I'm going to switch it on. If it trips that bulb, I'll switch it right off. Cross your fingers. There we go. So what do we see on the rectifier? Negative 43.9 volts or 43.8. Schematic says positive to negative 44 rail volts. And the positive is 43.6. Yep, 43.6. Negative 43.9. Let's see. I'm going to turn down these controls. Let's get an amplifier plugged in and see what happens. a guitar plugged in. Amplifier is plugged in. All right. Let's see what kind of luck I have. All right. Of course, I'm in very close proximities. Let's see if I can sort of like back up just a little bit. Let me get this cable down. Back off the volume pot. So I'm going to put it into the normal channel. Okay. I got no controls going yet. So the volume, I'm going to turn everything back down. I think I still might have a cable. All right, I have a cable in the effects loop. Damn it. I'm going to switch this amplifier off because I did something very stupid. I don't know if anyone's noticed, but I never took that diode where I placed it. Huh. Okay. Just gonna. If I have this in the effects loop, it's not going to get any preamp signal. Okay, so I'm going to switch it back on. Okay. Let's see, what am I touching? So we got tones, but they seem very distorted. obviously I'm not used to this amplifier at all. Let's see, turn down the got a like a fuzzy thing to it. This thing is dimed. Let me see if I can dial up. Seems decent. I mean, everything is out in the open, you know. What can you expect? Okay, I'm gonna switch that off. That seems quite loud. I don't know. I mean, shit. But I don't know if it's like, that's just the normal channel. Normal channels can be actually quiet. Here's the overdrive channel. We'll try that. I mean, it's hard to say, like, I've never had any experience with this amp, although it's much, much louder than it was. Turn my guitar volume all the way down. I'm gonna step away, because I got transformer hump, proximity. That doesn't seem good. So there is something working with this amplifier. So now what I can do is I can maybe trace a signal and see what happens. So I think now we got it to a point where it's actually fixable. Well, thanks for tuning in to whatever part this was. I think it's 7. Well, let's see, actually. I think I got everything dialed up wicked high on the master and the normal channel. Someone in the background is playing something. Let me just see this again. Maybe it was just the volume was too high. Okay, so let's see, overdrive. See how this is. See, I had the normal and the master all the way up before I even fiddled with the overdrive. Now the original complaint was that the bright cap didn't seem to work well. Let's pull the bright cap, see if it does anything. Oh yeah. That's jarring even. Push it back in. Well, I won't do that because it's not really connected in, but hold a second. How much overdrive, how much volume do we have? Let's try that. that's it for today. I think we succeeded. So I'll start bolting it together and testing her out.